Hi, I've been becoming more and more aware of an argument for the existence of God that it seems to me is the most compelling rational argument for the existence of God that I know. Now, I think probably on the whole, the most compelling arguments for the existence of God are personal and experiential. However, when it comes to rational arguments for the existence of God, it seems to me that the fine-tuning argument is probably the most compelling of all. It points toward there being a designer who designed the universe in a very specific way. As it turns out, the existence of the universe as we know it is on a razor-thin edge. And I recently read a book called Six Numbers. I forget the exact title, but something like Six Numbers. And this book, of course, the author is not a believer in God. The author believes in what's called the multiverse. He thinks that there may be all kinds of false start universes out there and stillborn universes and universes that didn't make it. And that the only reason we're here is because we're on that razor thin edge. But the point is that just Six Numbers, that's the name of it, by Martin Rees. This book basically says we are here on a razor thin cosmological edge. Well, I'm getting ahead of myself. Let's dive in. So there are several classical arguments for the existence of God. The two probably best known are the cosmological argument and the teleological argument. What is the cosmological argument? Well, the cosmological argument, basically, I sum it up with the sound of music. Nothing comes from nothing, nothing ever could. So that's it. The idea is that if there was never anything, then there could never be something. There has to have been something that caused the existence of what is. Otherwise, there would never have been anything. Now, the classical pushback, oh, well, then who made God? Well, that to me is a fundamental misunderstanding of what the argument is. The argument isn't that everything has to come from something. The argument is that everything we know in this universe has to have been caused by something. And therefore, there must be something outside this universe that caused this universe. And when I say that, I say nothing about the nature of the thing outside this universe that caused this nature. This universe. So that response, well, where did God come from, doesn't understand the argument at all. The argument is that this contingent universe needs something that's not in this universe, to have created it. So anyway, I'm getting off track here because this is not about the cosmological argument. However, I will say that although in the 20th century there was a lot of kicking and screaming against it, a guy named Fred Hoyle in Britain really argued strong for the steady state theory, which is the idea that the universe is constantly generating material. And of course, if you read the works of Stephen Hawking and others, they really wanted to believe that everything was going to go cosmic crunch again, that okay, it's expanding now, but eventually it's going to go crunch again. But after decades and decades of fighting it and not liking it because it seemed to be, no, that plays into people who believe in God. No. I have to say that scientists now pretty much have and I'm talking about atheistic scientists, have pretty much conceded that there was a beginning to this universe. For example, Alan Guth was a champion in the 1980s of the inflation theory, which after gathering more and more evidence, even atheistic scientists now have believed that the universe went from practically nothing to what we see today. The idea of a cosmic background radiation that was discovered in the 1960s. Again, this was not popular. It was not popular at the time. But the cosmic microwave background radiation basically says that there was this moment when the universe cooled down enough for all of its photons to be released, and so it is decreasing. But no matter where you were to aim a radio telescope into space, there is a declining background radiation. And here's the thing: if the universe was infinitely old, it would have completely dissipated by now. This says that there was a beginning. Scientists usually date this to about 13.8 billion years ago. But it basically says there was a beginning, and that it started with almost nothing, and then bam, we have this universe. Now, the thing is, a lot of Christians are resistant to the Big Bang, and I frankly don't understand why. Do you not understand what the idea of a Big Bang is? The idea of a Big Bang is that, bam, there was everything all of a sudden exploded into existence. Isn't that what we're saying when we say that God created the universe out of nothing? This fits exactly with what Christians believe about the creation. So I just don't understand, other than people don't understand what we're talking about when we talk about the world beginning, universe beginning with a Big Bang. The other thing of recent, and this is really in the last 20 years, it has been confirmed. Now, again, I'm not staking my faith on any particular bit of data. I'm just saying that as of right now, things are looking pretty good. Not only is the universe accelerating, Stephen Hawking has been shown wrong on so many of these sorts of things. The universe is not going to go crunch again, but the universe is not only expanding, but it is accelerating in its expansion. It does not at all look, according to the current numbers, that the universe has enough mass for it to eventually slow down and then re-crunch. This was called the oscillating Big Bang, 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 which could account for some sort of a infinitely crunching and re-banging kind of universe. But it seems like the universe's expansion is accelerating, and as one physicist put it, is headed toward more of a big rip than it is a big crunch. What does all this say? It says the universe had a beginning, which again, after all the smoke is cleared and 100 years of hemming and hawing, Einstein didn't like the expansion theory of the universe either. He introduced voodoo numbers into his equations, the cosmological constant, lambda, he introduced into his equations so that they wouldn't imply a cosmic rip or even an expansion at all. But Hubble confirmed, I believe in the 1920s, that there was in fact an expanding universe. All of this says is the universe had a beginning. The cosmological argument stands. Now, of course, it doesn't say what started. It doesn't say why it started. It doesn't say who started it, but it suggests that there was a start. And this plays into the classical argument for the existence of God. Now, of course, I mentioned that Martin Rees and others believe in a multiverse. In a multiverse, you have these universes that are, as far as we know, constantly bubbling out of something earlier. And so that our universe would just be the bubble that worked, as it were. Hawking, I haven't fully gotten my head around it. Hawking argues that there's some kind of a imaginary number-based origin that doesn't require beginning. I haven't fully understood what he's arguing about that, but I also know that he looked for a cosmic crunch. So I think that Hawking was running away from the kind of big beginning idea there in his book, The Brief History of Time. Okay, well, of course, a multiverse would not preclude there being a God. It would perhaps take the existence of the universe back one step. But the multiverse largely has been invented, I think, to try to escape the idea that there was a beginning, and thus the question, why did it begin? Well, the teleological argument. The teleological argument is the argument from design. And it basically says that there is too much razor-thin complexity in the universe for there not to be a designer. It's the idea that if you find a watch, William Paley in the 1700s, I talked about, when you find a watch, you assume there was a watchmaker. And so Paley was arguing that the universe is too finely designed for there not to be a creator. Of course, Paley wrote before Darwin, and so he did not anticipate Darwinian theory. This video is not about Darwin. I'm going to throw that aside and simply say, I'm talking cosmology here. I'm talking about the universe, that the universe itself seems to exist on a razor-thin edge that suggests that either we are the luckiest of all beings in the universe or the multiverse, or there was somebody who was looking for us. So even though evolution and chaos theory are sometimes thought to undermine it, you'll be able to see in the next few slides whether or not you think that it is compelling from a rational standpoint. Of course, the anthropic principle you may have heard of, which is the principle that Rees and Hawking and others take, is that of course the odds of us being here are absurd, but the odds of something being here is not absurd. And so there may be thousands of stillborn universes. And basically the anthropic principle says the only reason we're having this discussion is because it happened. And so we couldn't have this discussion if we didn't happen to be here. And therefore the fact that we're here suggests that we're just the lucky ones. We're the lucky ones of perhaps an infinite number of universe trial and errors out there. We just happen to be the one that worked. We wouldn't be having this conversation if it couldn't happen by chance. Well, you decide which approach you think requires greater faith. The one that says the only reason I'm here is because I'm the unlikely person that survived out of the millions who died. You know, of course, I'm the one. I happen to be here. Or whether you think that there might have been some designing that went into the universe. I mean, are there other are there 4-dimensional, 5-dimensional worlds out there that failed, and that ours just happened to succeed because it was the card that played the 3-dimensional? Anyway, it seems to make more sense that there was an intelligent planner for this universe than that. Well, of course, we're talking about this because we're the winners. Okay, let's get into the actual title of this video, which is the fine-tuning argument. I want to present some cosmological arguments here. Well, they're about the cosmology of the universe that are arguments for the design of the universe. Okay, first, our universe has 3 basic spatial dimensions, which leads to what we call the inverse square law. So, for example, if you know Newton's law of universal gravitation, it has an r squared in the denominator, which means that as the distance either increases or decreases, according to the square of the distance between two things, gravity either increases or decreases. Now, here's the thing. It's the same, by the way, for the electromagnetic force. The electromagnetic force between, if you have 2 charges, they attract each other in accordance with the, again, there's an r squared in the denominator of the electromagnetic formula, which means that the charge increases or decreases, the force of the charge increases or decreases according to the square of the distance between 2 charges. Now, here's the thing. If there were more dimensions, we would have a inverse cubed. For example, if there were 4 dimensions, we would have an inverse cube law. Or if there were 5 dimensions, we would have a inverse to the 4th power law. None of these universes, if they could exist at all, would work because planets would fall into the sun. Because the inverse square law is what allows for there to be orbits, elliptical orbits. And so a universe that didn't have 3 dimensions could not develop into the world as we know it, because you wouldn't be able to have planets and things like that. If you had fewer dimensions, I mean, it's hard to even imagine there being a flat land kind of universe. How could that even work? Basically, what we're saying here, and this, by the way, William Paley recognized this in the 1700s, that the inverse square law is necessary for life as we know it. And if God had not created, if there weren't a universe with 3 dimensions, then it wouldn't work. Here's another one, the arrow of time. So the laws of physics on the atomic and quantum level do not actually require that time only move in one direction. In fact, Richard Feynman famously suggested that antiparticles could actually be particles moving back in time. Ingenious thought. I don't know exactly what that means, but it sounds really smart. But basically, there is an arrow of time because of this Big Bang. Cosmic expansion implies that time only moves in one direction. And also, the inevitable increase in entropy implies that time only moves in one direction. If I drop this cup on the ground and it smashes, there's not going to be any universe likely where that cup will fall, that if I take the pieces and I drop them, that they're going to recollect into the original cup, because entropy only on the whole increases. So time has an arrow, and the fact that time has an arrow, if time didn't have an arrow, there would be no history, there would be no story of salvation, there would be no directional relationship of God with the universe. The only way that there can be a story at all, as we know it, although this might be an interesting short story or novel to write, maybe I'll get around to it one day. But the only reason that we have the Bible or the story of God is because time moves in one direction. Now, here's the thing, and I can't remember. I might say this in a later slide. It seems to me that God created just a little bit of asymmetry in the earliest universe for this to happen. It seems like what's called the weak force. The weak force has just a little difference between the symmetry of the other particles and such would have implied that time could go maybe either direction. But God has created just a little bit of asymmetry in the universe that creates an arrow of time. Without that arrow of time, there could be no relationship between God and the universe, or at least it would be very interesting to try to figure out what that would look like. So here I get to this one. There's a slight asymmetry of matter. So the inflation of the earliest universe at one point released an enormous amount of energy, which consisted of both particles and antiparticles. Now, I don't know if you've ever seen Star Trek, but the warp drive in Star Trek ships is a matter-antimatter reactor. Basically, don't get worried. There's not enough antimatter, anywhere for us to have annihilations like that. But if matter and antimatter come together, they annihilate into total energy. The early universe seems to have had a pretty even balance of matter and antimatter. But here's the thing. God created just a slight little asymmetry, a slight tiny bit more bias toward matter than antimatter, so that when in the early universe the matter and antimatter were created, almost all of it annihilated, except it left just enough matter for us to have a universe. And so it's that little slight, if there wasn't that little slight asymmetry that God built into the creation, there wouldn't be a creation. We would not be here if God had not put just that slight little asymmetry into the creation. There's also a slight asymmetry in the distribution of matter. So God created a ratio between the energy rest mass of matter, mc squared, and gravity. The ratio between the energy of matter and gravity is just right. It's about 1 to 100,000, that it creates just enough ripples. Now it's hard to detect gravitational ripples. Gravitational waves have recently been confirmed. They were hypothesized decades ago, but even in the last 5 years, we had a confirmation that gravitational waves, ripples, actually do exist. It's not much, but the gravitational ripples of the initial expansion and inflation created just enough irregularity to distribute matter slightly unevenly so that we can have galaxies and so forth. If you look at the maps, the mapping of the cosmic microwave background of the universe, there are just some slight little irregularities in it. Those have made the universe as we know it possible, and it wouldn't have happened if there hadn't have been just a little bit of irregularity. Okay, the expansion rate. The expansion rate, this inflation, this boom, is just right. It's like Goldilocks, not too fast, it's not too slow. If the expansion force, boom, had been greater, there wouldn't have been any time for stars and galaxies to form. It just would have been matter going on forever in a scattered kind of way. But the relationship between this expansion force and gravity, if gravity had been greater, the stars would have crunched too soon for the stuff of life to be around. And so we have this delicate balance between the explosive force and the gravitational force that is just right for stars and life to develop. The ratio, this is something I read in Rees's book. The ratio of these two must have been within 10 to the minus 15th of 1 in the earliest universe. If it had been 1, we'd have had a standstill, but that's a period with 15 zeros, or with 14 zeros and a 1 after it. That's really small. That's a razor thin edge for the universe to develop as we know it. Here's an interesting one to me, because I like chemistry. The binding force of the nucleus. So there's something called the strong nuclear force. It binds a proton with a proton and a proton with a neutron. It holds the nucleus together. You may know that like charges repel, so to have protons and protons, which are both positive, in the nucleus, how is that possible? Well, there's something called a strong nuclear force that holds it together. Now, the hydrogen in the early universe was, for a very small period of time, was fusing together into helium. About 25% of the universe has helium in it. And this probably goes back to the very earliest moments of creation. But the binding force of the nuclei was just right so that didn't happen too quickly, and so it didn't happen too slowly. If it had happened more quickly, if the ratios had been more quickly, then all the hydrogen would have become helium, and we would have no stars. And if we had no stars, we would have no heat, and we'd have no people. But this allowed, the binding force is just right to allow heavy elements to form in just the right amount of time, so we don't get too many or too few for life to work. Carbon, by the way, this is amazing. Carbon has just the right resonance with a certain energy amount to be able to form before the thing it's kind of formed out of, beryllium, decays. Otherwise, we're carbon-based units, right? Life is based on carbon. And so it's kind of like, I'm trying to think of an illustration. Let's say that I'm on a train and I have a hook, and I just have to catch this bag as I go by. Carbon just happens to have the right energy to catch a beryllium and is it a beryllium and a hydrogen? But anyway, it's a beryllium and a helium. Just the right energy resonance to form a carbon. I forget what the other thing with beryllium is. To form carbon at just the right energy. Beryllium, in that kind of situation, doesn't live very long. And so carbon has just the right hook to catch the beryllium before it decays in the early universe. So the energy resonance of carbon is just right on a razor thin edge for it to form under the conditions of the early universe. And that's because the binding force of nuclei, the strong force, is just right to do that. Now, in fact, all the force, this is fascinating to me, all the forces of nature are just right for atoms to work. So first of all, gravity, we think of gravity as strong because it holds us to the earth, but that's only because the earth is so big. Gravity on the atomic level is very weak. So gravity is too weak to mess up the atom, and it's too weak to crunch the universe. Like we were talking about the expansion rate and the gravity being just right. Gravity's too weak to mess up the atom or crunch the universe. It's only 1/36 of 1/10 to the 36th power of an electromagnetic force. That's 1 over a 1 with 36 zeros after it. Now, the strong force I was just mentioning is strong only within a little scope. And so the strong force is the strongest force, but it only works far enough to hold the nucleus together. It's not strong enough to mess up with the electrons that are going around the nucleus. The weak force, I already mentioned, is just asymmetrical enough to give matter a slight advantage over antimatter. So this is just amazing how these forces are just right to do what they're supposed to do. Strong force is strong enough to hold the atom, the nucleus together without interfering with the electrons. The electrons are perfectly balanced with the protons. The gravity is not strong enough to mess that up, but the gravity is just right for the expansion and contraction of the universe. And then lastly, of course, the Earth. The Earth is not too hot. It's not too cold. If it was hotter or colder, the water wouldn't work. It has a stable orbit. It doesn't have another planet crossing it the way that Pluto crosses Neptune in one part of its orbit. The Earth is just the right orbit. Gravity is strong enough to hold, the gravity of the Earth is just strong enough to hold the atmosphere in place, but it's not too strong to crush us. If we lived on Jupiter or something bigger, we couldn't move. And there were just the right bacteria to produce oxygen in the atmosphere. So this is just, I think, the beginning of many, many aspects of the creation that are fantastically fine-tuned. And the question is, isn't it amazing that all of these things are just right for the universe to be here the way it is? If it was different in any respect along these things I'm talking about, we wouldn't be here doing this video. And so you can either say, well, we're only having this discussion because we're the lucky ones, or you can say there was an intelligent designer who set all these things up just right, in just the right way, so that we could exist and be loved by him, be loved by God. And there you have it, the fine-tuning argument for the existence of God.